In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet visualizing data. I'll leave a link in the description below so you know how to access this free worksheet. Our directions for the first two problems are to draw a dot plot for each data set. Now, a way a dot plot is set up is that we're going to have essentially a number line underneath with the values that are in our data table. So let's start by drawing that number line. And we're going to put tick marks for our different data points. So looking through the numbers, we see 4, 5, 6, and 7. So let's mark a tick mark for each of those. 4, 5, 6, and 7. Now, a dot plot really helps us visualize the count. So how many of a certain data point we have. So what we're going to do is for each number in our data set, we're going to put a dot at where that occurs, stacking one dot on top of another. So let's start with 4. We have 1, 2, 3, 4 different 4s. So we're going to put 4 dots above our tick mark labeled 4. So 1, 2, 3, and then 4. Now we're going to go through the same process for 5. There's 1, 2, 3 different 5s, so we're going to put 3 dots above our tick mark labeled 5. So here we have 1, 2, and then 3. So already from visualizing this, you can see that we have more 4s than we do 5s because there are more dots. There's one more dot for our 4 than 5. Let's move on to 6. We have 2 for 6, so doing 2 dots, 1, 2, and then finally 7. We have 1, 2, 3, 4, 5, 6, 7, 8 dots above 7. So 1, 2, 3, 4, 5, 6, 7, and 8. Notice that when I draw my dot plot, I keep all my dots in line. So the first dots, second dots, third dots, fourth dots, and so on are all kind of within that same horizontal plane so that I can visualize my data. And it is obvious from this chart that there are more 7s than any of the other numbers. And that's how we draw a dot plot. Let's move on to number 2, drawing a dot plot for even more data. Now you can see for number 2, we're dealing with more of a spread, meaning that we have a larger difference between our numbers. Up above, we only were dealing with 4 different numbers with a difference of 3. 7 minus 4 from up above was only 3. That was the range of our data. However, now we have numbers ranging from, since these are in order, we have numbers going from 41 all the way to 68. We need to account for each of these, but it's going to be very tedious to write out every number. So what I recommend is let's draw out our number line, writing out the even numbers. So there's my line, and now I'll do my tick marks. So we know we need to have a tick mark for 41, so I'll put it there. Then we have 42, which I will label, 43, 44, which I'll label, and so on. So I'll finish out this number line quickly. Feel free to pause the video and finish it out on your own. And there we have it. I have my number line with all my even numbers labeled. Now let's start filling in our dots on our dot plot, representing the count for each of our data points. So we have one person that's aged 41, so I'll go ahead and put a dot above 41. Then our next number is 47, so I'll locate 47, which falls between 46 and 48, and put a dot there. Then we have 1, 2, 3, 4 separate 50s, so locating 50 and drawing 4 dots. 1, 2, 3, and 4. Now moving on to our next number is 52, which also has 4 different people of age 52. So drawing 4 dots above 52. 1, 2, 3, 4. And remember, we're keeping those dots in line so that we can easily see and visualize what numbers have more and less data points, which right now, 50 and 52 have the same exact number of data points in our data set. There are 4 people aged 50 and 4 also age 52. Let's continue on. We have 2 people of age 54, so that will get 2 dots. Then we have 1 with the age of 62, 1 with an age of 64, and lastly 1 with an age of 68. So from this, looking at this visually, you can see that we kind of have a clump of data around the 48 to 54 range. We have 1 younger person all the way over here, and then we have a couple of older people over here. So this just helps us visualize that data. Let's move on to number 3. For numbers 3 and 4, we're going to be drawing a stem and leaf plot for each data set. So the structure of a stem and leaf plot is kind of like a table. We're going to have our stem on the left-hand side and our leaf on the right-hand side. And the next part of the stem and leaf plot is our key. For our key, we have to decide what values are going to be our stem and which values are going to be our leaves. And when I talk about the values, I'm talking about how we're going to split these numbers up to capture them in the table. So you can see our numbers go from 9.2 to 69.2. So from about 10 all the way up to about 70. I think a good stem for this would be a value representing our tens place. So if we were to write a key, we could say something like 2, then the line dividing our stem and leaf, and here is a 5. So this is our tens place, and this is our ones place. So this number, 2 with the line and then 5, would represent the number 25. So let's go through each of these numbers, writing them in our stem and leaf. But first, before we even do that, let's write how many different stems we'll have. Because you can see we're going from 0 in the tens place because we're not quite at 10, all the way to 60 in that tens place. So 0, 1, 2, 3, 4, 5, and then 6. So starting with our first value, 9.2, rounding, that's a whole number of about 9. So that's 0 in the tens place and 9 for our leaf. There we have the number 9. Next, we have 15.6, which rounds to a whole number of 16. So we're going to put a 6, 1, 6, that would be 16 because this stem represents our tens place. 10 plus 6 is 16. Again, 15.8 rounds to 16, so we'll put a 6 there as well. 22.4 rounds to 22, so we'll put a 2 next to our 20 stem. Then 26.4, that's going to be a 6 within our 20 stem. Now we're moving on to our 30 stem. So we have 34 and 34, so that's 2 4s. And then our 34.8 rounds to 35, so we'll write a 5. Then we have 38.8, which rounds to 39. And 39.6, which actually will round up to 40. So that's going to be a 0 for that leaf with the stem of 40. That 4 in our stem represents the tens place. Then we have 45.2, so we'll put a 5. 50.4 will be a 0 within our leaf with our stem of 5. Then we have 51.6, so that rounds to 52, so writing a 2. 55.6 rounds to 56, so we'll write a 6. 55.6 again, that's another 6. 56.6 rounds to 57, so that'll be a 7. And then we have 69.2, which rounds to 62. 9. So how does this help us visualize the data? Well, again, we can kind of see that a lot of our data falls in that 30 to 50 range. From 50 to 60, we actually have the most numbers in our data set. Because keeping those leaves in line, we can tell we have 1 for each of our stems, 2 for stems from 10 to 50, 2, 1 for 30 and 1 for 50, another 2, but here in that stem of 50, we have the most numbers. We have 5 different numbers in that leaf for the stem of 50. So this stem and leaf is like a dot plot, except a little more detailed. As opposed to just putting dots, we're putting the values. Let's move on, continuing our stem and leaf for number 4. For number 4, we're dealing with a lot larger numbers. So we're really going to have to think about, what do we want our stem to represent? Well, if we see here, because they've ordered our numbers for us, we go from $604 all the way up to $58,042. So even if I was to split this up by hundreds, I would do 600, 700, 800, 900, 1,000, but I'd have to do that all the way up to 58,000, which would be pretty tedious. So maybe we can look even further. What if we split this up by, let's say, 1,000? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then I have to go all the way up to 58, even if I just did it by the 1,000. I think the best number to do this by is by the 10,000s. So we're going to have our stem, we're going to have our leaf, and our key is going to actually be, we're going to have our stem as the 10,000s and the leaf as that 1,000 place. So if I was to write a number, let's say 3 and 5, well, that's representative of 35,000. So up above, our stem represented the tens place and our leaf represented the ones place. Here, our stem represents the 10,000s place and our leaf represents the 1,000s place. So get ready to do some more rounding. But first, just to make sure we have enough room to write all of our data, let's capture the stems. Our smallest stem will be 0, since 604 is less than 10,000, so we'll put a 0 there. And we need to go all the way up to 50,000 to capture this 58,000, so we need to go all the way up to a stem of 5. So 0, 1, 2, 3, 4, and 5. So now that I have all my stems, let's go ahead and write out the leaves. And when we do this leaf, since our leaf represents the 1,000s place, we need to round to the nearest 1,000. So for this first data point of $604, rounding to the nearest 1,000, that's 1,000. So I will write a 1 for my leaf. Next, 2,998, the closest 1,000 is 3,000. So I will write a 3 for my leaf. Here, rounding to 4,000, we'll write a 4 for the leaf. 4,812 rounds to 5,000. So a 5 for the leaf. This next one rounds to 5,000 as well. So another 5. 5,867 rounds to 6,000. So a 6. 9,433 rounds to 9,000. So a 9. You can see that we had a lot of leaves within this stem of 0, which shows that all of these are less than 10,000. Now moving on to my stem of 10,000, we have 11,498, which rounds to 11,000, which means I'm going to be writing a 1 for my leaf for 10,000 plus 1,000, which is 11,000. This next value of 11,654 rounds to 12,000, so writing a 2. 12,504 rounds up to 13,000, so writing a 3. 15,675 rounds to 16,000, so writing a 6. 19,260 rounds to 19,000, so writing a 9. Then we're moving on to 21,911, which rounds to 22,000. So we've moved on. Now we're on our next stem of 20,000 plus a 2,000, a leaf of 2. Then moving on to our next stem of 30,000, we have a number that we need to represent as 36,000. So if this stem is 30,000, then our leaf will be a 6 for 36,000. Next, moving on to 40,338, that rounds to 40,000 when rounding to that nearest thousandth, which will be a 0 for 40,000. And then lastly, our largest number, 58,000. So making sure we capture that, here's our 50,000 plus an 8,000 will be 58,000. So you can see, looking at this data, that the majority of our data lies between 0 and $20,000, with a few other data points, this one seeming like an outlier, meaning that it's well beyond the range of the majority of our data. But we can go over that in later videos. For now, that's how you visualize using a stem and leaf chart. And once more, one of the key components for a stem and leaf is figuring out that key so that you can capture data to help you visualize it. Let's move on to our next set of directions. For the last two problems on this worksheet, visualizing data, we're going to be drawing a box and whisker plot. Now, a box and whisker plot is all about the quartiles, and a quartile is splitting your data up into quarters. How we do that? We need to find the median of our entire data set, and then we need to find the medians of what's left of the middle of the data and what's right of the middle of the data. But first, let's start with our number line, similar to the dot plot. So zooming into number 5, our data is nicely in order, which helps when finding the median, because remember, the median is the middle of our data, and our values go from 37 to 54. So let's go ahead and mark, let's say, the even tick marks. So we'll have 38, and so on. And then I'll go ahead and mark the tick marks in between just to help us when we go to graph this as a box and whiskers. Now, the first step is to locate that median. And how we do that is we find the middle of the data. So I like to cross out the lowest and then the largest value, the next smallest, the next largest, next smallest, next largest, working back and forth, crossing out numbers until I get to that middle value, which happens to be 47. If you get two separate values potentially in your middle, then you take the average of those two numbers. But we have our median as 47, so we're going to mark that with a line. This is the start of our box and whiskers. Now, since 47 is that median, and it was the number that was perfectly in the middle, we didn't have to split the middle, we're going to now look at the lower side, those values less than our median, and we're going to find the middle of that data. So let's work on that. Crossing out the lower, then the upper, lower, upper, lower, upper. See, I have 3 crossed out here and 3 crossed out here. I have 2 potentials for my median value of the lower part of my list, but they happen to be the same value, so the average is going to be 44. So knowing that my average there is 44, I'm going to now graph that. So I'll circle my medians here so I remember that the median fell right in between those, which, since they're the same number, is 44. So again, we're going to draw a line at 44. This represents the lower quartile, which is the 25th percent of our data. Here is the 50th percentile, or 50% of our data, or the number in the middle of our data. Now we have to find that upper part, that part that represents the 75th percentile. So just like before, crossing out the lower, and then the upper, lower, then upper, lower, then upper, you can see that our median of our upper half of our data, that 75th percentile, falls between 51 and 52. So taking the average of that, or the number that falls in between those two, will be 51.5. So we're going to actually be trying to capture a decimal on our number line. So here is 51. So I need to move over a little bit to get 51.5. And again, I'm going to draw that line right there, trying to capture 51.5. Now, those are all the parts we need for our box. So we're going to connect the top together and connect the bottom together. So there's our box. Here we can see is the 50th percentile, 75th percentile, and 25th percentile. So breaking that up into quarters. But we haven't captured the rest of our data yet. We need to graph the lowest number, which is 37, and we need to graph the highest number, which is 54. So we know that range of our data. How we're going to do that is we're going to put a point at 37, so locating 37 and putting a dot, and then we need to put a point at 54, so locating 54 and putting a dot. Now you connect the dot to the middle of the edges of the box with a straight line, like so. So here is our box, and there are our whiskers. And from visualizing this, you can see there's a wider range between our lower 25% of our data than there is the upper 25% of our data. And the more you practice with box and whiskers, you'll actually get into more advanced concepts such as outliers. But for now, let's just work with these simple box and whisker plots. Moving on to number 6, our data is life expectancy. So we have some numbers ranging from 74.2 all the way up to 83. Just to make this easier to chart, I'm going to draw my number line representing my whole numbers. So I'm going to go from 74 all the way up to, let's do 84, rounding this up. So here will be 74, here will be 84, halfway in between will be 79. There we have it. Now remember, our first step is to locate the median of our data, because then we can split our data into two separate sets where we look at the lower half to find that lower median or the lower quartile, and then the upper half to find the median of our upper half of our data for the upper quartile. So locating the median, we're going to alternate crossing out lower and larger values. You can see I have 1, 2, 3, 4, 5, 6, 7 crossed out, and then 1, 2, 3, 4, 5, 6, 7 crossed out. If I was to try to cross lower and upper again, I would cross out all my data points. So we know the median falls between 79.7 and 79.8. So the number right directly smack dab in between those would be 79.75. So on a number line, it's going to be hard to be completely accurate, but we need to roughly plot 79.75. So 79 3/4, a little bit less than 80 would be approximately here. Now, because we've located our median and it fell between those two numbers, you can see that we've divided our data set up. Here is our lower list, and here is our upper list. So now I'm going to work with those to get my quartiles, my 25th percentile and my 75th percentile. So crossing out lower, then upper, because remember our median fell between those two, so we're going to include this in that data that's less than the 50th percentile. So cross out lower, upper, lower, upper, lower, upper. Again, we have two numbers that we're looking at. So we need to graph the point that falls between 78.2 and 78.4, which is 78.3. So about right here on our number line. So now we took care of that lower half of our data. Now we just need to do the upper half. So again, the lower value of our upper half and then the upper value. Lower, upper, right between 81.3 and 81.3, which is 81.3. So capturing that on our number line, 81.3. Now that we have the middle of our lower data, the middle of our entire data set, and the middle or median of our upper data set, we can connect that box. So our box for our box and whiskers is done. Now we need to capture that lower and smaller value. So our lowest value is 74.2, our smallest value, 74.2. Drawing a dot on that. Here is 74, so roughly 74.2. And then our largest value, 83.8, putting a point along that, and then connecting that to our box, forming our whiskers. And there we have it. So again, Box and Whiskers is all about finding medians, the middle of our data, and then finding the middle of the halves of the data to get those quartiles, breaking it up essentially into 4 different parts. And that's a few quick examples on visualizing data. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. And as always, don't forget to like, subscribe, and share. Happy learning!